It's a real pleasure to be here, Michael, wherever you are. Thank you for the opportunity. We've got about a half an hour, and what I'll do is I'll share some thoughts around how our science journey at AIG has been for the last 3.5 years, so maybe the first 20 minutes, and tee it up for any questions and thoughts that we could share as a team. So I joined AIG about 3.5 years ago to create what is arguably the first C-suite science function with data in parentheses in front at any major corporation at this level of seniority. And the idea very simply was that we are a very large company, which as one of the organizers actually referred to as the granddaddy of the industries with respect to data creation. And to give you a sense of scale, we pay out about $135 million in claims commitments every single day. So that's data that we're gathering around when things go bad, how things go bad, why they go bad, and what we could do to mitigate that looking into the future and manage the outcomes once the event occurs. So the challenge and the opportunity for us as a team is coming in as a function in a mature industry, in a mature organization, where there are existing pillars of analytics capabilities, although I wouldn't call them data science capabilities, and figure out how do we bring a fresh perspective that could shape decision making. And part of our challenge is, while we realize that we've got a ton of data around structured and unstructured internal data around events ranging from the NFL lawsuit for their head injuries to the meteorite shower in Siberia, through to Costa Concordia, and pretty much anything and everything that you read about in the daily news of events going bad. We've got a ton of data, structured and unstructured, but obviously we live in a world where there's just a sheer data explosion, and how do we harness the external data, which is less contextual, but is also less biased than what we have internally. And the third piece of it is, how do we invest in new data sources? Because we think that in the insurance world, much like much of the rest of the world, data is going to give us a key advantage. So that's sort of that's a little bit of a background around the creation of the team. The way we thought about the challenge is that while certainly harnessing the data and driving insights and is a big part of the change management problem or opportunity, you're still a support function, you're still a new horizontal function. So really the bigger challenge for us is not just the data engineering, not just the data science, but how you bring all of that together to ask sophisticated questions and apply science, and data being an important part of it, to improve the quality of decision making. That's really the challenge. So that it actually starts not with the data problem, but it actually starts with a problem that is independent of the data issues. So it starts with conceptual thinking, abstract reasoning, problem structuring skills. You then sort of say, to the extent that I think there's a data-driven answer to this, how should we, what data sources, internal, external, structured, unstructured, could help us measure this risk and solve this problem analytically? And that requires some data engineering capabilities to go into the bowels of our systems and pull out all of the unstructured data and for text mining purposes and such. And last but not the least is, once you come up with the insights, how do you make decisions differently? How do you get people to think and act differently on the basis of that? Why do we care about that? We care about that because there's 16,000 underwriters at AIG who are essentially in the business of pattern recognition and prediction. Whether it is a World Trade construction site, or whether it is any and every pretty much type of risk that you could imagine, commercial or consumer, life insurance or health insurance, we're in the business of pattern recognition and prediction. And historically, this industry and this organization has based its decision making on the power of heuristics. So many of the principles that you'd associate with Daniel Kahneman from Thinking Fast and Thinking Slow fame, and the challenges around human decision making and how to augment human decision making with data, are highly, highly germane to us. And oh, by the way, we also have 16,000 claims adjusters who are paying out $135 million every single day. And a big part of what they do is pattern recognition and prediction. And our challenge then is not necessarily how do you supplant human intelligence with machine intelligence, but rather how do you find that harmony so that they're as appropriate, the balance between them is a little bit different, and we're benefiting from both the human context that people would know that isn't necessarily captured in the data form, but yet we're benefiting from the institutional wisdom of AIG as a company. So that's a challenge, and the way we've chosen to organize ourselves is we think of our world roughly in sort of three buckets. One, about probably 20% of what we do is things that we can solve for in the near term that might take us a week or a month or two or what have you from concept through to deployment. A big chunk of what we do is take on those big hairy problems, and I'll give you some examples of this to make this more real, to really help drive fundamental change in some critical part of our business. And then the last piece of what we do that is equally important and over time even more so is thinking through how do we harness emerging capabilities such as computer vision, deep learning, natural language processing, and sensor technologies, among many others, to shape how we think about risk, to not just predict risk better, which obviously has its value, but to mitigate outcomes, to reduce the level of risk in society. And why we care about reducing the level of risk in society is that we think the challenge is that there's not enough understanding and appreciation and penetration of insurance, whether it's life insurance or health insurance or other forms of insurance in society in general. And the industry does a pretty decent job, maybe average job, of understanding who's risky and why and how much. But we are not very particularly good at thinking through how could we use that data and those capabilities to flip it around and say, how do we mitigate outcomes? How do we reduce the likelihood of adverse events occurring? Or when adverse events occur, how do we reduce the likelihood of those adverse events getting too expensive and painful all around? So those are some of the principles that guide how we think about our work as a team. Let me maybe give you a few examples. So we have roughly about $6 billion in revenues from a line of business called workers' compensation. And the idea here is people get hurt in their workplace, whether you're a truck driver or whether you're a factory worker or whether you're at a construction site, things go bad. You pull your lower back, your shoulder hurts, you have all sorts of challenges with accidents happening. And the question we asked ourselves is, number one, can we tap into a broad range of data assets to predict claims that look suspicious? So it's probably not much unlike what you might expect from the work that a Palantir does. There's lots of data, and if you could actually catch the needle in the haystack, then you pretty quickly realize that you've got challenges with individual situations that you could mitigate before it explodes on you. So that's an interesting piece, but that's a very, very small piece of the total value that we think we can contribute to this whole space. The second part of it is once something does occur, how do you predict the likelihood of complexity looking into the future? So in other words, you could have a bunch of different decision trees depending on how you manage a particular patient care situation or a particular claim. And could we look into the future? Could we look into 90, 180, 360 days and beyond and fold those decision trees back to today's terms and figure out what is the likelihood that a particular event could lead to legal complexity or lead to poor medical diagnostics and therefore take longer for folks to get healthier and back to normalcy? And if we could predict that, how do we fold that decision tree back to today's terms to much more proactively manage some of these cases to prevent future complexity, to reduce the likelihood of pain and suffrage, and through that get people healthier faster and back to their lives where they'd like to be. So that's sort of one application. The bigger picture for us in this space, really sort of the true north, is saying, how do we harness the power of sensor technology to understand what actually causes accidents? So in other words, can we thoughtfully partner with with external firms to figure out how we can understand, for instance, if it's a factory workplace, how worker movements, how their body movements and what they're doing, what they're lifting, what they're not lifting, what time of the day for how long, and so on and so forth. Can we start collecting data of that nature that might help us understand what behaviors or what physical movements connect to damage to human tissue, and soft or hard or whatever, pulling, straining ligaments and so on and so forth. So that's sort of, we think the power of that is not just better prediction, even though there's a huge amount of value in that. The power of that is that we can then work very actively with our clients to say, how do you mitigate that? How do you catch that before it happens, such that you're reducing the likelihood of workers getting hurt? That, we think, is really, really the ultimate sort of true north for the industry as a whole. In the meantime, what we're also doing is we've got troves and troves of unstructured data. We've got troves and troves of unstructured data around what goes wrong, when it goes wrong, and it could be things such as a hotel chain and theft in particular locations, or it could be slips and falls in certain hotel branches in the winter months because they don't have rubber mats and things like that. So what we're starting to do is we're starting to tap into much of that unstructured data, the handwritten notes, to garner insights around what's actually going wrong, why is it going wrong, and helping some of our larger clients understand how do you actually get ahead of that and how do you reduce the risk, because reducing the risk has huge supply chain implications for them, going well above and beyond just their insurance premium. So changing the nature of what the industry does through the power of data and analytics is something that we think is critical. We also recognize that quite a bit of this doesn't just happen through pure data science as we define it, i.e. that it's really the intersection of several disciplines. Case in point, I alluded to the fact that earlier that we've got claims adjusters that are in the business of pattern recognition and prediction. So to arm them with a richer sort of suite of capabilities or tools, if you would, we've applied some of the principles we learned in our work with Professor Daniel Kahneman to say how much noise is there in decision making, how much volatility is there in decision making. So to the extent that you've got individuals seeing the same scenario and making meaningfully different decisions, how do we drive more convergence by bringing them more consistent, getting them closer to consistency in how they see patterns? So some of the capabilities we're applying are deploying tools such as tools along the lines of what you would associate with a Zillow to bring more consistency and to bring more structure, rigor, and discipline to decision making in what we do as an insurance firm. So the other big part of what we do is, saying, like I said, harnessing technology and data that are emerging in a broader sense and thinking about the applications of that to insurance. There's two dimensions to this. One dimension is each of these new technologies, name anything that you can think of, whether it's a business model such as the sharing economy or whether it is 3D printing or autonomous vehicles and such, they have insurance implications because they have risk implications, because they're changing the paradigm of how we think of risk. And it creates new risks that perhaps didn't exist before, and it creates new dimensionalities that changes the game of some dimension of risk in a pretty meaningful way. That's one piece of it. The other piece of it is this vertical that I'm part of is in many ways a horizontal vertical, if I may say so, i.e. any change that you think of in any part, in any technology has implications for us to tap into to find ways to reduce risk, to better predict risk, and go way beyond just lending balance sheet strength, so to speak, to our customers. And so the question is, where do you get started? There isn't any obvious answer, but we took a suite of problem statements that we thought could be particularly well solved and thought through how do we harness computer vision and natural language processing and sensor capabilities with an eye on fundamentally changing some critical aspect of what we do. And why we care about computer vision very much is that we want to translate images and video into data because that has implications for risk. In fact, one of the efforts that we have underway is a partnership with NYU where we're trying to solve the problem of how do you figure out whether an intersection is safe or not. And the way we are trying to do that is to collect data around movements of objects at that intersection 24/7, 365, and connect the data from that to near misses, i.e. imagine any single object at that intersection, whether it's a bicycle or a motorcycle or a bus or a pedestrian or what have you, being represented by 4 dots. And we are in our research efforts with NYU is trying to measure what is the rate of change between this object as identified by these 4 dots and this different object as identified by a different set of 4 dots. And how does that start getting us more data around near misses as opposed to waiting for 5 years or 10 years and having to collect data on 10, 12 fatalities to point out that an intersection is not safe. That obviously has profound risk implications. It also has profound public policy implications, as you can imagine. On a similar vein, the problem of, or the opportunity of natural language processing, if you think about what we do in big parts of our organization and industry, is we have documents, we have legal fees related to case history and analysis of what went wrong in different scenarios and trying to connect some past experiences to a legal situation today. Or we've got claims adjusters that might be having a 5, 10, 20, 30, 50, 100 page or even bigger document that they're trying to synthesize to try and get some context around. And the question and challenge for us is, obviously, keyword search technology is wonderful. It's been around for 20 years and is remarkably passé now. But the challenge for us is, how do you synthesize the context to answer specific questions that a reader might have for a 1,000-page or a 500-page or longer document in a matter of seconds in a way that provides that reader the context and the information that he or she needs to make decisions faster. That fundamental capability has much broader implications to what we do, but clearly we think that that's another area where we want to place a significant bet and will have implications to disrupting some critical part of our business model. So, you know, the team's been around, like I said, we've got about, actually we're up to about 180 team members. And at one point in time last year, I'm proud to say that we had, I think, 3 of the top 10 Kaglers in the world. We recently had a couple of our team members who won a KDD Cup that was trying to predict the likelihood of attrition in a MOOC, which was is a fascinating problem unto its own. And what we've learned is that that change, you know, to drive, sort of to steer a ship this big, takes quite a bit of patience and resilience. And that as much as we love the intellectual piece of the data and the insights and the answers, there's a human element to this. And the human element is you're trying to get people to think differently and act differently. You're trying to get them to make different decisions. And equally importantly, you're trying to get them to make decisions differently. So the challenge for us is, how do you play the role of a catalyst in that evolution? Because the ultimate power isn't in saying, here's the 10 problems that we've solved through the power of science or the power of data science, and here's what we should do. There's certainly a huge amount of value there, but it's still only part of the story. The real power is to get people to think more analytically, to embrace the power of data, and to be able to use that as something that augments their human intelligence. And in order to do that, turns out it requires a fairly sophisticated complement of capabilities, and we're still certainly in the process of continuing to tweak that on a daily basis. And the other piece of it is there's sort of a human element, and then there's the piece of very rarely is a model unto itself useful. because you got to figure out how do people make decisions from a technology standpoint, from a workflow standpoint, from a system standpoint. And so we find out that the challenge around integrating the insights in a seamless way to make it user-friendly, to enable, to improve what they're doing today, and then to add layers of sophistication is really the challenge and opportunity for us. So a big part of that answer for us has also been around this whole concept of design thinking. So our learning in the last 3 years has been that certainly science and data science is at the core of what we do, but equally important are all of these complementary set of capabilities. And the real magic happens when you can bring them together in some sort of a harmony to work together. And if you think of the world just in isolation, then you're going into, metaphorically speaking, you're going into battle with just one weapon. And in reality, you need a combination of weapons to achieve what you're trying to achieve. So that's the path we're down. It's been an amazing 3 years, and my hope and aspiration someday is that we'll do work that is worthy of writing a book of having introduced a whole new capability at a level of seniority that most mature industries have yet to appreciate. So that's my 20 minutes time. I'm almost down to the second, so I want to tee it up to see if you have any questions or thoughts that you might like to share. Please.
Yeah, you mentioned at the beginning of the talk that one of the things you're trying to get around are some biases with the internal data sources you work with.
Yes.
What are some examples of biases that can trouble you guys?
So the challenge with internal data is it's very relevant, but if you don't sort of, two things, if you don't sort of create a test and control environment, then you end up modeling a biased set of data and then restricting your sort of data knowledge, and then sort of systematically you narrow your understanding of the world. So that's one piece of it. The other piece of it is there's just so much amazing data in the world around us. So our ability to harness that thoughtfully and systematically is very powerful. For instance, when we try to model the likelihood that a large building, take this for instance, might have some sort of a risk associated with it, we found out that the car theft index in that zip code is a predictor of the likelihood of some claim associated with that. Now, it could be vandalism, it could be theft, it could be a number of things. But thinking more creatively and being more expansive in our understanding of what data is available and how it might connect to what we're trying to predict is powerful. Another example is we wanted to predict the likelihood that a small business would have a loss associated with it. So think about your local mom and pop store, pizza, dry cleaners, and so on and so forth. And we found that the distance of that business from the closest fire station turns out is predictive of the likelihood that there might be a risk associated with it. Now, it's one of many factors, but my point is that if you sort of think that you have all the data that you need, then you're narrowing your choices. So you've got to be expansive. You've got to be much more externally oriented so that you're augmenting your internal worldview with that outside view. Please.
How do you get such a huge organization to keep this data science?
Excellent question. So the question, just for everybody, is how do you get a huge organization like this get started to think and act differently? The first thing is grit, is what I'd say. You gotta have thick skin. You gotta have grit, and you've got to be able to see the world through their lens and understand what their objections are. And if you focus only on their intellectual objections, those are easier to solve. In some ways, a piece of cake, frankly. It's their emotional objections that are much harder. And so understanding them and getting them to recognize that you don't have the arrogance to assume that you have all the answers. You have the confidence to know what you know, but you have the humility to be able to learn and understand. And that the real sort of, again, magic happens when you bring sort of that expertise with an orthogonal worldview or a certain degree of naivety, I think is absolutely critical. The other thing that you do is you don't look for symmetry. You're not trying to win over the entire organization in one fell swoop. So pick the 2 or 3 pockets where there's certain openness. And don't define your success as an insight. Define it as an outcome. So what behavior or decision are you trying to change? Why will your customers or investors and colleagues be better off as a result of that? So be thinking about that holistically and pick off the 2, 3, 4 early successes that you can get, and don't worry about winning over the Luddites. Focus on the early adopters. Question back there.
Thanks for the presentation. You mentioned this was a multidisciplinary problem. So how do you go about building multidisciplinary teams? So the business folks,
Yeah.
the statisticians, the design thinkers. How do you put?
So, for instance, within science, I don't actually care what academic background somebody has. I care about their ability to learn, and I care about their passion for evidence-based decision making. So as such, we've got former professors of philosophy on our team. We've got people with behavioral economics backgrounds. We've got people with psychology backgrounds. We've got people with design thinking skills. We've got people who are in rapid application development skills and such. So we within science, we try to assemble a pretty wide range of skills. And we've got a bunch of economists as well, because we're not trying to put everybody in the mold of a pure data scientist who's coding and building models. In fact, I would say that from a team of around 150 to 180, probably half of them actually code, and code from a data engineering standpoint or code from a data science standpoint. So the other half is actually a combination of skills that are critical and complementary to what we do in the core of our team. Question in the front.
Yeah, how do you justify your sort of your boss's time for R&D? So exploration of new sort of R&D and new state of the art.
Yeah.
The industry. How do you justify the time that it takes?
So a couple of things. So that's hence, I alluded to the fact that we have a portfolio of work that we do that's sort of short, medium, and long term. And so what we try and do is we make sure that we are whetting the appetite and the needs in the short and medium term. And we give ourselves the room, therefore, by earning the right to push on the research frontier more and more. That's sort of number one. Number two is really sort of starting that research not just from a pure research standpoint, but starting with a few problem statements that you care about and saying, boy, how can I connect these technologies to these problems, and how would the world be different and better if I could help achieve that? So starting with that as opposed to being just purely theoretical in research is critical. And oh, by the way, having a boss who's hugely supportive helps too. And I happen to be reporting to the CEO, who's an amazing creative thinker, who comes from the capital market space and who had this vision. In fact, he's the one that tries to push me more toward the research front, and I'm the one that tries to bring him back to that sort of center a little bit. So it's quite a role reversal in a funny sort of a way. Yes, back there. Yeah.
Is that sort of changing the relationship that insurers have traditionally had with the customers, and do they go along with it?
So I think what they find helpful, especially larger customers, institutions and such, is the industry as a whole has been isn't exactly very warm and fuzzy, right? So if you don't have an adverse event, you just keep getting your bills, and sometimes they go up for random reasons, and you say, well, why is mine going up? I haven't really done anything or had an adverse event. And when it does go up, they either drop you or they raise your prices by 2x or what have you. So what we're seeing is, again, we haven't sort of systematically scaled this anywhere close to where I would like to see it in the coming 12 to 18 months. But this whole dialogue around reducing risk is very relevant to them, because it's got profound implications that go beyond just the price that they pay. So again, much like any set of human beings in any large organization, not everybody is equally receptive. But boy, if you get those X% of your customers to engage with you differently, that changes the dynamic of that relationship. It creates more value for all parties involved. It reduces risk. And the beauty of that, from my perspective, of reducing risk, is that it actually expands the coverage of life insurance and health insurance, not just in the US, but particularly in the developing world, where it's nowhere close to what it is in the US. That's the true north, I think, for this industry to aspire for. Question in the front, or no? Sorry, you hold him. Sorry, thank you. Yeah, sorry.
When you're speaking about preventing risk, specifically you gave the example of
You were talking about preventative risk, specifically with the example of accidents in a hotel lobby, for instance. How do you quantify and measure metrics around preventative risk, such as that, when you start to make changes into the community, for instance? How do you measure those, and how do you gauge where you're putting that value back into your products?
Yeah. So we're in very, very early stages of what I just described. So we don't have the science behind that quite anywhere close to perfected as of yet. But I think that ultimately it shows up in the frequency of adverse events and the dollars associated with them when they do occur. And my hope is that the industry as a whole can lower that, and by doing so can lower the cost of insurance, and by doing so expand the reach. So I think it's highly, highly measurable, but I don't want to focus just on the economics piece of it. So to the extent that it changes the nature of the dialogue we have with our customers and repositions the role of insurance in their minds, that's very powerful as well. So there's, you can call it some version of Net Promoter Score, you can call it some measure of the economics, but there's a variety of factors that I think that go into it. The beauty of it is, this isn't a $50 million investment. This is literally 10 people or maybe 12 people doing this on a very seamless, efficient way at a relatively low cost. So the upside is tremendous. So we don't really worry about quantifying the ROI quite in the same way. So I know I've got this sort of bright red flashing thingamajig in front of me. So maybe one last question, if anybody in the room has any, or not. Well, you've been a very good audience. Thank you for your time. Pleasure.